In this video, we're going to continue our algebra applications with Maxima, and we're going to talk about complex quantities. Basically means complex numbers, quantities in a general manner, and we're going to start with this document. Suppose that we want to find even roots of negative quantities. Square root of minus 1 is the unit imaginary number, which in Maxima is represented by percentage I. Square root of minus 3, you keep the square root of 3 and multiply it by the square root of minus 1, which is I. And the square root of minus 8 turns out to be minus 1 to the 1/4. Now, I'm going to take this and I'm going to try the following. Rectangular form of that. It's 2 to the 1/4 I plus 2 to the 1/4. Sometimes Maxima doesn't simplify things, and so this needs to be written as rectangular form because it turns out to be a complex number. It's not as simple as a single imaginary number. So I apologize for that. Square root of minus 1 is the number I, which is the unit imaginary number, and these are the first 8 powers of it. So I minus 1 minus I 1, and then they start repeating themselves. The first powers are these, and they repeat. A purely imaginary quantity will be a negative number raised to the 1 to the n when n is even. So let's try some cases here. Square roots mostly. Operation with purely imaginary quantities. You just end up summarizing results in terms of I. This one turns out to be a real number. This one imaginary. This one's real. And the last one, it's real. Now, when you add a real number to an imaginary number, you get what is called a complex number or a complex quantity. So complex quantity has a real part and an imaginary part. If you take the real part and change the sign of the the sign of the imaginary part, you get what is called the conjugate of that number. For example, the conjugate of minus 3 plus 5i is minus 3 minus 5i. Operation with complex quantities, Maxima calculate those very simply and give you a generic complex numbers z1 and z2 equal to x1 plus iy1, x2 plus iy2, and you have the summation, subtraction, and multiplication with real values. Here is the z1, z2, z3, z4, and we're going to combine them in some additions. I tried rat simplify to factor out things here, and actually float to give me floating point numbers. Subtractions. There's my subtractions right here. Multiplications. Now, multiplications you have to use rat simplify or expand to obtain them into this rectangular form where there's a real part and imaginary part. Division. Maxima will not try to simplify that, but if you want to simplify it, we're going to follow the same thing as we did for radicals. We are going to separate the numerator from the denominator, multiply the numerator by the denominator by itself, and then divide the new numerator and new denominator. And this result is what makes it makes into the rectangular form, where there is the real part right there, y1 times y2 plus x1 times x2, and then these two terms are multiplied by I, so this is the imaginary part, and then everything is divided by a real number, x squared plus x2 squared plus y2 squared. The simple form is just the function rect form, which is rectangular form, and it will give you basically the same result as this but expanded. And so we can try divisions of these two terms, of these two terms, of these two terms. Now, what is a complex number? Well, we can represent it graphically in a system of Cartesian coordinates, except that now the vertical axis, the abscissa, is multiplied by I, so it becomes imaginary numbers in the vertical direction, real numbers in the horizontal direction. And so this will be a pure real number, this will be a pure real number, P1, P2, P3 and P4 will be pure imaginary numbers, and then these are complex numbers where 7 real part and 4 imaginary part. So the coordinates x, y represent the real and imaginary part of a complex number z. If I have this complex quantity, I can separate the real part and imaginary part. This function get p of z will give you the coordinates, imaginary part and real part and imaginary part, and the purpose of that is for plotting. So if I get a number here, z, I'm going to get the coordinates at that point, and I should be able to plot that one. This one I'm not sure it's going to work. Let's try it. No, it doesn't work. So it's fine for plotting one point, but I thought I had worked out the ways to plot several points, but it's not that simple. So let's say it up to here, and with that we're going to finish this video about complex quantities.